Check. Okay. Hello. So this is a non-typical introduction to Akka remote actors with the Raspberry Pi, or blinky blinky lights, if you prefer. If you're here because you want to look and learn about practical applications of the Raspberry Pi with remote actors for Akka, there's other conferences and other talks over there. If you're here because you want to see, an introduction to what remote actors can do, and you want to see, blinking lights, okay, stick around, right room. So there you go. So I have a bit of a disclaimer to start off with. I'm going to get some volunteers, probably from the front row at some point, to come up and press some buttons. They have some exposed leads on them, so it's 5 volts and 16 milliamps, so really low. It's hard to hurt yourself with. But if you lick them and hold them across your heart or something, it's called evolution in action, and nobody's going to feel sorry for you. Yeah, the Darwin Award, exactly, yeah. So a little bit about me. My name's James Townley. I'm from Edmonton, Alberta in Canada. That's just a little bit south of Cold Lake Air Force Base, where Wolverine is from Marvel, yeah. Okay, so up north, cold. Right now it's probably minus something Celsius. So it's winter there, full on. I work for a company that is in Ottawa, Canada, called YopWorks. And YopWorks is a light bend partner. We're also a Hortonworks partner. We do training, consulting, and we tend to think of ourselves as expert in distributed systems and microservices. So that's the stuff I was required to say to be allowed to come. So I'm done. We can actually get on with the rest of the talk. So I want to introduce the characters and this story that I'm going to tell. So the first character here is the Raspberry Pi. So just a quick show of hands. Who here has heard of the Raspberry Pi? Who here has used one? Who has used one for educational purposes? That's what they were designed for. So specs are on the screen. I don't know anyone who's used them for educational purposes, mainly for fun. Specs are on the scene. The points that I really want to bring out about the Raspberry Pi is on the back there, right at the top of one of these guys, is a giant row of pins. It's called a Gpio port, or the general purpose in-out port. And what that is, it's a little tool that's created for software programmers to allow them to pretend to be electrical engineers. So you have some options with that. You can say, turn it on, turn it off, or listen to what it is if it's either on or off. So that's what that's for. So in my case, it allowed me to create a whole bunch of little lights that show up there. So we have a couple of other characters in this story. One is Mr. TP-Link down there, a traffic coordinator. I went with the wired network option here because, well, wireless networks, presentation, yeah, let's make it as hard as possible, right? So the other character we have here is the pretentious Mac, who will also play a role in this story we're telling. And it has USB ports, so it's not that pretentious yet. So let us begin our story. So once upon a time, there were 4 Raspberry Pis. They lived a simple life, operating somewhat independently. So I'm going to just go ahead and show you what that means. So I'm going to go and find the command, and I'm going to just push some code to them. So this script just basically is, hey, start running this particular Java command. So it's going to just go there, and while we do that, I'm going to show you the code for that, because it's really simple. It doesn't have actors in it yet, and you can see it on the screen there. It spools up a little library called Pi4S, which is a wrapper for something called Pi4J. And it has a while statement in there, nobody kill me later, please, that just loops indefinitely and flashes some lights. So in a second here, we're going to see all that network traffic having hit those guys, and the compile will complete, and they should start blinking any second, please. Oh, okay, good. Oh. Whew. That was the most worrisome part of the whole presentation. All right. Thanks. All right. So we've got a really simple system here. We got independent operation, blinking away at their own random intervals. So the only logical course of action for me to take at this point is to kill them all. And I'll just do that now. Okay, so they all turn back on at this point, hopefully. Oh, as soon as I hit the button. So they've all turned back on. So for the Gpio port, it happens to be holding low when there's no other command telling it. So that's why they all turn on at the end, is because there's no data being sent to it. So it's just going to its default. So that's going to bring us to the next part of our story here. So one day, Miss Boss, the pretentious Mac, arrived and decided that she wanted to tell all of these little Raspberry Pis what to do. So I'm going to get that code running here. This is our part 1. And just while that's loading up, we'll have a look through the code here. So we're going to look at the code that's going to be on the Raspberry Pis first. So we have created a config factory and loaded some config. I'll look at that config with you guys in a second. We create a simple actor system for each Raspberry Pi. And then we create an actor on each Raspberry Pi of this Raspberry Pi listener actor. So I'll show you that. And the important thing here is that it has its own Pi4s. And down here we have this case class blink, which takes a color and a time, and calls that Pi4s with blink for this much time. It's pretty simple. So we have some stop stuff in there, but I'm not going to go in there yet. Most people have had that actor conversation about how do you stop an actor, and that's another talk that takes a day. So by now, hopefully all the lights have turned out. Yeah, that means they're ready. So we'll have a quick look at the config, and then we'll run that. So here's our config. So it's pretty simple stuff. Setting up just like a regular actor. Oh, wrong config. Here we go. This is a better config. So we set it up just like a regular actor. That IP address variable is just the IP address of the local device. And you're basically saying, use this TCP transport from Netty in this case, and here's our host name and here's our port. On the master side, which we'll look at the config first and then we'll go and look at the code there, we have a list of all the remotes and their IP addresses. DNS works as well. And we're just saying, yeah, use the same transport and here's who I am. Then we can look at that master code. So we have a config factory again. We have a list of our remote actor addresses from the config file. We have our own actor system, and then we create a bunch of actor refs to that. So what we're doing here is we're just mapping the IP addresses to the actor selection here. And then we're going to call this cycle all lights thing, which should, in theory, get all the lights on all of the machines to run. So let's run this and see what happens. Now, pay very close attention to the beginning of this. Okay, did anyone notice something happen at the beginning there that was a little different, that you weren't quite expecting? They didn't all line up when they turned on, eh? So that's going to, introduce a little bit of a topic here, which is what type of guarantee we have. So with our delivery guarantee with remote actors, by default, we're getting a at most once delivery. So that means that you don't actually have to get any messages. And you really notice that at startup. They haven't quite got it in their head what they're meant to do yet or something like that. And usually you get a few that miss a message, especially with the Raspberry Pis over a network, and it just doesn't work so well. So that's just one thing to keep in mind when you're working with these remote actors, is you have that at most once guarantee. Gets important. So back to our storybook here. So Ms. Boss was really unsatisfied with the work that all of these Raspberry Pis were doing. And she decided that she didn't want to necessarily tell them what to do, but she also wanted to tell them how to do it. Which brings us to our next remote example. So I'm going to kill everything again, because it's nice, just to make sure everything's cleaned up. And I'm going to start pushing this out, and then we'll have a look through the code. All right, so our next example here is the remote actor. Now, a few of you are thinking, what? Because that's it. There's no other libraries here. I'm not hiding anything in the imports that's not obvious. It's just the config system and the actor system. I can prove it. That's it. And that's our remote actor. We're going to deploy just that to the Raspberry Pis. And you'll notice something here as well, is this time I deployed it and the lights didn't go out. And the reason for that is because I haven't actually pushed the library that controls the Gpio port to it yet. So we've just set them up. Now the config's a little bit different here. So if we look back at our config, there we go. You'll see that the only difference really is this little deployment line. And it's basically just saying that this is a remote actor. That's a deployable remote actor. Same sort of setup there. Master just happens to be the name of the actor system. I realize now that it's probably a bad name, a little confusing. It's just the name of the actor system. It doesn't have any connotation other than that. So there we have it. We have this tiny little thing that's been pushed to all those Raspberry Pis, hopefully all done by now. And let's have a look at our main class. A little bit different now. We're still loading all of the IP addresses from the master config. We're still going through and we're getting the address from those IP addresses, getting the full address for the actor. This time we're creating this props, which is a class of the Raspberry Pi listener actor. Just the props at this point. And then what we do is we iterate through all of our addresses and create a props with deploy, and the deploy of a scope of the remote scope of the address. That's a mouthful. So what that translates into is we're saying, hey, we're going to deploy to this remote actor and then run the code and then have it handle all of our messages. So we got another thing here which is going to say, okay, send all your messages and cycle each of the lights. And there we go. We're going to push the code to the Raspberry Pi, run it, and watch all the lights cycling. Hopefully. It's thinking. Oh, ooh, okay. So now they're all cycling. And we still had that same problem we had earlier. It's the at most once delivery. But at this point, something else has happened, right? We've sent all of our code to that. So some of the more astute or more security aware of you at this point are going, wait a minute. Did you just set up your system so that you could have remote code execution really easily? It gets better. You see, when you're using a Raspberry Pi and you want to use the Gpio port, the process that needs to access the Gpio port needs to be root. So we've just enabled remote code execution as root on our Raspberry Pis to make this happen. Okay, so that's no good. I don't care even if you're in a secure network, that's not a good idea. The amount of practical jokes your fellow developers could play on you with this, not fun. So the people at Akka aren't stupid. In fact, they're quite smart. So what they've done is they have created some tools that allow you to secure this stuff. This is just right from their example stuff. I haven't filled it in or anything, but you get the idea. So you can set up SSL and protocols and key stores and trusts and all that good stuff. So you can actually lock this down and make it a little bit more secure, which you definitely want to do if you're running it over some WAN. If you're local, you may not want to do it. Yeah, you have your own internal arguments as to whether or not it's a good idea. All right, so continuing our story, the remote actors, the Raspberry Pis, got fed up. They were tired. They didn't want a boss anymore. Bosses are lame. They're old school. They wanted to work together, but not with this overseeing despot machine. So that brings us to our last example here. And I will start pushing the code. All right, now you're gonna randomly pick two people. Maybe yourself. This is your button, don't lick it. And maybe yourself. This is your button, don't lick it, yeah. You can pick up your buttons, just don't push them just yet. It's still thinking. So let's have a look at this code really quickly here. You can stand to the side. When you push your button, raise your hand when you go ahead and do that, just so people know who's pushing what. All right, so here we go. We have our code for this. Now this is only a remote at this point. There is no master. This is all pushed to each of the individual Raspberry Pis. So again, in the config, we've listed all of the Raspberry Pis, told every Raspberry Pi about itself. And we do the same thing we did on the master in the second example there, where we load all of our actors that exist already on this machine. I've introduced another little magical trick here, which is listening. And that is going to listen to these buttons that these guys are going to press in a second and send some messages based on that press of that button. So the listener is just very simple. It's just do some various things depending on which button gets pressed. So it should be deployed. All the lights turned off, so go ahead and press your buttons. Raise your hand when you do. Yeah, you have fun. Like, press it a bunch of times. It's cool. All right, so we've got a couple of different patterns there. And now what we have is a system where all of these remote actors are talking to each other. They're talking back and forth, and they're operating in a situation where they can each talk to each other. So there's no master, there's no slave relationship anymore. It's just each actor has the possibility of sending a message, and that can be received by any one of these other actors. We're doing it, somewhat randomly at this point as to which actor it goes to for this button over here, and for everybody over there. So you have a couple of different possibilities with that. So that leads us to our next step here, which is they live happily ever after. But of course, they didn't really, because you're still dealing with this sort of, at most once delivery. So what's next? What's the next topic here? What's the next thing I want to do with these Raspberry Pis and blinky lights? Well, how about Akka cluster? Which is sort of the evolution of these remote actors, where you're changing your delivery specification, and you're getting to take these and put them in a large cluster and work independently. Why Raspberry Pis? Well, because it's really easy to demonstrate things with, and they're small, cheap, and portable. So with that, I'd like to say thank you guys all for listening, and I hope you've enjoyed yourself. And I had a bunch of people who allowed me to come here at Yachtworks and spend some time with you. And if you have any questions, now is a good time.
We've got 2 minutes for questions. Ask away.
Did you get to try out any Scala native, and do you know if it works with Akka as well? Or is that...
Sorry, if it works with?
Did you have a chance to maybe try it out on Akka native, or sorry, Scala native with Akka, or is that not something?
The question was, have I had a chance to try it out with Scala data?
Scala native.
Scala native. No, I have not tried this out with Scala native, but wow, do I ever want to. Yeah. Any other questions? Yeah?
Why does it take so long to download the program to start up the Raspberry Pi?
So the question is why does it take so long for it to download the programs and start up Raspberry Pis? I haven't spent a lot of time benchmarking that. My current theory is the fact that the disk on these things sucks. Right? We're talking about a little SD card running on a USB 2 port. So I think a lot of it is just generating the bytecode is slow. Once it's up and running, it runs like the boondocks. It's a quad-core processor in there, and it's 1.1 megahertz. It is ARM 7, right? So it runs really well once it's in memory, but running from anything from disk or dealing anything on Raspberry Pi with disk is always slow. Yeah?
Yeah, I got 2 questions actually. Number 1, how did you assign the IP address? And number 2, what was causing those first messages to get lost?
Okay, so 2 questions there. First question was how did I assign the IP addresses? Well, this is just a switch, but right beside it is a DHCP server, which is also a Raspberry Pi. And I just did an assignment on it to reserve the IP addresses for the Macs. The second question was,
What was causing the background volatility and instability regarding the first messages that were getting lost?
okay, so the question was basically why didn't they all start blinking at the same time, and why were some messages lost?
Yeah.
Okay. The reason for that is that there is a period of time while the actor is spinning up that if any messages do come in during that period of time, it may not get them. That's the guarantee that it has, right? It's part of the guarantee is at most once delivery. So there is no way to actually ensure that that message gets there without introducing a lot more code, pre-roll or ACK type stuff. And very quickly you created Akka cluster if you go down that path. Yeah.
We're out of time now.
Oh, my apologies. Thank you guys again. If anyone has a few seconds just to help me rip this off the stage really quickly, I'd appreciate it.